Okay, hello, this is Dr. James, and today I'm going to show you how to build, this is a audio oscillator that I built, tunable, has a piezoelectric speaker in the front, transformer, 2N3055 transistor, just one transistor, makes it oscillate, and I'm using one of these, what is it, a 14200 battery. It's lithium ion battery, very high power density. Have a screw up here which tunes a ferrite rod in and out through the transformer here, which tunes the frequency. Let's take a look at this guy. Okay, so here's our device. I put a little on and off switch here. It makes a lot of noise. You can tune the frequency by tuning this rod in and out. Okay, that brings a ferrite. Okay, so this tuning thing brings a ferrite rod down through this transformer that I wound. It's a 1-to-1 transformer. And we just have a resistor and a capacitor for the startup and oscillation of our transistor. Okay, a very cool device. I 3D printed these parts. I'll probably put them on Thingiverse. Anyway, let's get going. Okay, so here is our circuit for the audio oscillator. This is our transistor, 2N3055 high power transistor, goes up to about 1 megahertz. So we have a battery. I'm using these lithium batteries, about 4 volts, and here's a piezoelectric speaker, which is basically a capacitor in parallel with one side of the 1-to-1 transformer. I have a variable coupling here, which actually basically tunes the inductance of this side, which is a resonant circuit. And here's the feedback to the transistor, emitter, base, collector. So it feeds back into the base, and the main power comes from the 4 volts down, charges up the capacitor, goes through the coil, and then it's modulated by this transistor here. Anyway, so this is the main oscillation circuit here. This L and C determines the frequency of the oscillator. And what I found, this is a pull-up resistor. It pulls the base up to a higher voltage so it can oscillate. It basically brings it closer to switching on. And I found that this 100 nanofarad capacitor in parallel with this helps the oscillator start up. For some reason it doesn't like to start up very well if it's just got a resistor there. So anyway, there is the full circuit for this device. We have our soldering iron up to temperature. Here's our piezoelectric device and our transformer. Let's just try to solder these things together. There we go, we got the speaker here soldered up, and so we'll move on to the next step, I guess. Okay, so I tried to recreate this circuit here with just putting clip leads. Basically we have a battery. It's going to come down through our resonant circuit. The LC goes to the shell of this guy is the collector, just like up here. Okay, and the base is going to be hooked to the battery, or the emitter is going to be hooked to the battery, and we have 2 leads coming off the secondary of the transformer that are going to go between the base, which is down here, and the emitter, and I'm not sure which direction they need to be. Okay, so I hooked it up one way, and we'll just try it and see if this thing oscillates. Okay. Actually, maybe I should, it might be too high a frequency. I think it's supposed to be like 40 kilohertz, so maybe I can't hear it. Let's just try sticking this thing in there. Let's bring the frequency down. Okay. We put an inductor core through there, which should bring the frequency down into the audio. And I don't hear it oscillating. Maybe I'll switch the leads on the secondary of the transformer here and see if it'll oscillate then. Swap the two leads on the secondary, which is I'm using that as the red windings as the secondary. We'll see if this oscillates. Still nothing. Still no oscillations. Okay. So maybe I will try to put a 22k ohm resistor. This is 22 kilo ohms. Okay. From the base to the positive to pull up the base a little bit to get it oscillating. Okay, so now we have our 22k ohm going from the base to the positive to pull up the base a little bit. And we'll see if this oscillates. It seems to be oscillating. Not super stable though. Seems to only oscillate for a little bit and then it stops. Maybe I'll try reversing the leads and see if that helps. Okay, I reversed the leads on the secondary and we'll try this. Nothing. Yeah, so the other way is getting close to oscillating. Maybe I just don't have the right value of resistance in there. Okay, so here we have looks like red, and it should be 2K, and it looks like it is 2K. So let's try putting that would be a factor of 10 lower resistance. Put that in place of the 22K and see if this thing oscillates better. So now we have our 2K resistor pulling up the base, and let's try this guy out and see if he oh, by the way, I don't know if I mentioned before, these are some cool batteries that I found. 14500. It's actually a lithium ion battery the same size as a AA battery, so it fits in the AA holders, but it's 3.7 volts, basically 4 volts. Okay. Anyway, let's try her out. Okay, let's try pulling the core out. Look at that. Very cool. It's tunable just by sliding the core in and out through it. Wow, that is super annoying, isn't it? Anyway, very cool. It's working exactly the way I want it to. Okay, so here is a 550 ohm resistor. I'm going down in resistance. And let's try that one out. Okay. Okay, that one seems to start up the oscillations much more reliably. Who knows, I may have to go a little bit lower because it's not 100%. But it's a lot more frequently than the higher resistance ones. So that could be the key, is we need a little bit lower resistance to pull the base up and get it oscillating. Okay, very cool, huh? I got my nylon bolt in there, and I believe this is like a Y-size drill. I have to check that, but I believe that's what that is. And this is a Vivor lathe, and I'm just pulling out the center of it so I can get the ferrite rod into it. Okay, there's a finished bolt, and Let's take our ferrite rod. Make sure it fits inside. And there we go. Look at that. Perfect fit. Okay, I think we're ready to set to go. I want to have more travel, so I'm going to actually machine another one of these bolts and probably line it up down below it to try to get the threads lined up and glue them on together. Okay, I'll put the cutter piece on there to cut the top of the bolts off. Okay, so with this bolt, I cut off the top of it. Oops. There's a top on there. So I want to continue the threads on, so I need to cut off the top. And then I gun drilled the center. And see how this part came out. Okay, there we go. Look at that. Beautiful, huh? It's got the threads on there, so we can adjust it. Very cool. We got our, I'm only going to be able to put two on here, I think. Our bolt, threaded rod thing, and a nylon nut. And I just lined up the threads so that the nut can go from one threaded rod to the next, like so. There we go. So I think our component is ready for showtime. Okay, very cool, huh? Okay, so I'm soldering the two red leads of the transformer to the base of the emitter. Okay, getting this thing soldered up. Okay, I replaced all clip leads with wires and soldered this guy up. Let's take a look at it. It's kind of, a lot of stuff's upside down here. Okay, so here we have our piezoelectric ultrasonic speaker. Here is the special transformer that I wound from that wire that I ordered off of Amazon. Here is a 2N35 is 3055 transistor, NPN, and I put a heat sink on it, and I have a socket on the back to hold, so I can replace the transistor easily. Here's a kind of a cool battery that I found. These are actually lithium-ion batteries, but they're the same size as AA batteries, 14500. They put out a lot of power, and they have a switch. Okay, so let's test this guy. What I found is the oscillator is not starting every single time. There we go. I'm not sure if it's, if I fiddle with the circuit, it might be the resistor, that pull-up resistor that I'm using. See, I'm using a pull-up resistor here to bring the bass up so it will kind of force it to oscillate. But maybe it's not the exact right value. Okay. And I'm just using one battery because I don't want to overpower the speaker. The speaker is supposed to be, I believe, 16 volts max. Not peak to peak, just max 16 volts onto it. Let's take a look at the waveform here. We have our circuit hooked up to our oscope. Let's just stop this. This is really annoying. And I will try to measure the frequency. See, the voltage here is about 16 volts, so I don't want to go with more voltage on the batteries because I don't want to blow out the speaker. And let's see, I want to change the cursors. Okay, since this is a weird waveform, this is not a sinusoid. I was thinking it'd be a sinusoid, but it's not. So we're looking at about 6 kilohertz there. Okay. And so that is the upper frequency with no ferrite in there. And I have my ferrite rod, which I modified so I can screw it in and out. I'll have to build some kind of structure to hold that. But let's do run stop, and we'll see what the lower frequency limit is, what this guy is. So there's the upper. Okay. And so there is the lower, and it's still a very distorted waveform. It's not sinusoid at all. Okay, so what are we looking at there? About 1.3 kilohertz. Is that right? Oh no. What, 1.42 kilohertz. Let's see. Is that right? 1.3 kilohertz. Okay, that's the cursor up there. Let me just recheck. I might have looked at the wrong frequency. Oh, let's see. Okay. Let's stop this thing. Yeah, no, it's about 6.66 kilohertz for the upper. I might try changing this resistor here and see how the circuit changes. Okay, so I hooked up my resistive meter to the circuit and it's telling me about 420 ohms. Is that what that reads? I don't know. Maybe, yeah, it might be 400. Let's see, green, blue, brown. I have to look up the chart because I don't remember those. Anyway, here I have a capacitor. It's about 100 nanofarads. It's probably supposed to be 100 nanofarads. And let's try putting that into the circuit across the resistor here. Okay. Okay, so I put that capacitor in parallel with the pull-up resistor, and now it seems to start every single time I put that 100 nanofarad capacitor in there. Every single time they turn the switch on and off. It's still got this funky waveform, but I guess that's something I can deal with. Could always put a filter on it to try to make that more sinusoidal. It looks like the circuit's working pretty good now. Okay, very simple circuit. Very cool, huh? So I got my new 3D print and just checking it out to make sure all the parts fit into place. Speaker fits there. I guess the heat sink doesn't really have anything to keep it sliding from left and right, so I might have to tie that down somehow. Glue it or something. Here's our coil. I forgot to cut a little slit to have the wires go through. Maybe next rendition I'll have that. And here is our screw. And it goes into this guy here. Sits on top. So you kind of screw this guy in and out. Very cool, huh? Okay. There's our device. It's very tall, huh? Just hot gluing these parts together. And looks like they're fitting pretty good so far. Okay. Get these all lined up. Okay. And here is our part where we're going to tune the magnetic field. Let me let that dry. Very cool, huh? Here's our speaker. Turn it on. Okay, seems to be working. Very cool sound generator. Okay. Glue this last bolt in here so we can tune it with. Okay. Cool, huh? Anyway, this is Dr. Jane, and thanks for watching.